Anyway, I think we're ready. If we're ready.
Sure.
All right. So every time we do this, I try a new opening and fail, and then I move back to the old opening. So I'm just going to go straight to the old opening here.
Okay.
Hello and welcome to another episode of Tech Deck Karaoke. And this episode, we are joined by James Brodsky with Google's Google Cloud security team. James is a brilliant security technologist with a hell of a pedigree that I'm not going to butcher. So James, welcome. Please introduce yourself to our audience.
I'm James Brodsky. I'm the head of the Global Security Architects at Google. I'm based out of Boulder, Colorado. I've only been at Google for, about 9 or 10 months, although it seems like much longer than that. But I've been around the industry a very, very long time, over 25 years working at companies like Splunk and Tripwire and IBM and a whole bunch of other places that I'm not going to mention.
Awesome. And so your team, the Global Solutions Architects, they obviously span the globe, hence the global title. But they've got from what I'm seeing is a bit of a blended role. On one side, they're helping to insert cutting edge security into a full solution and architecture within the customer from that big picture perspective. But on the other hand, they spend a lot of time enabling your internal teams on driving more value into the customer. Yeah,
about 50% of my time on the team and throughout the rest of the team members, we spend about 50% of the time working directly with customers. And so that's our most strategic customers, some of our largest customers. Sometimes they're not large customers at all. Sometimes they've got something that's particularly strategic to us or something that we're incubating, in some way that we want to get involved. So that's the first thing. So the other time is spent doing exactly what you said, doing a significant amount of enablement. We have about, 200 or 300 pre-sales technical sellers within my little tiny corner of Google, and we're trying to make them the best security savvy technical pre-sellers that they can be.
That's awesome. And so they get to take that like fresh frontline information and relate that back to make sure that what they're training the internal people is current, accurate, and what's being seen in the field.
Absolutely. We get involved with all the new stuff. So, I've been spending a lot of my time recently on something called Security Command Center Enterprise and Chrome Enterprise Premium. These are just like new products that Google has launched over the past 9 or 10 months. So they're really, really fresh, really, really new. Lots of different amazing features that have been coming out surrounding them. Some of them work, some of them don't, but eventually they're all going to work. I guarantee it, 100%.
Well, I love that, and I pointed out because I love the leadership fortitude it requires to take what you could assume is some of your heaviest revenue generators and pull them off of revenue generation to be able to scale that knowledge out. And it's hard to do, but it's required.
It is required. If I don't take the smartest people we have in the field, or maybe the most veteran people that we have in the field, how am I going to scale people that maybe aren't as familiar with the technology or maybe haven't been around the block as many times as some of the men and women that are on my team? I want to be able to scale our capabilities to as many people as I can, because it results in better security outcomes for customers and obviously more dollars in the bank for Google as well. That's a nice thing too.
Awesome. Well, I just noticed that Sabrina Schaefer is also here, and I'm legally obligated to allow her to introduce herself. So Ms. Schaefer, welcome.
That's very funny. I am so beyond excited for today's episode. I have seen James in action, and he is no joke. He knows his stuff, and he's also very honest. So I have sort of begged him before we jumped on to haze Joe, and so let the fun begin.
Yeah, it feels like you've been asking me to do this for like 6 months now, and so I'm glad we were finally able to do it.
Personal favor. It's a personal favor. Yeah.
And for our audience, I know we always say that we're very excited for an episode. The fact is we are, and it's not drug induced. It's just that Sabrina and I have no life outside of tech. So this is the most exciting thing in our month.
Yeah. I don't have any life outside of tech either. So I'm glad you know it.
Excellent. Well, without further ado, I am going to attempt Mr. Brodsky's content with no clue of what he's brought to share with you. And we'll see how this goes. We're going to be talking about practical use cases for AI in security operations. And I love the title already. I love where we're going with this, because in keeping with the pattern I've seen from James, he's talking about the practical side of hype. How do we actually use this in today's world to create an outcome that we need? And so practical use cases for AI and security. And that's an interesting topic to be talking about, because as we know from the hype cycle and the bubbles out there, the future is now. Everyone's talking about AI, but we're not hearing as much buzz about the real world practical implications of it. And in places, especially that may not be as marketable, in the operation side, in the security side, in the infrastructure side. And I think this is one of the places where AI is really mature enough to help us do these things. So I'm excited to see what James has to say about it and what I'm going to make up to his slides. First, AI has the potential to bend the curve on age-old cybersecurity challenges. When we talk about the curve on age-old security challenges, when we look at security from the dawn of information security, or even better, before information security was really a thing we talked about, we started with connectivity. We started with things like the internet. And the internet's original roots were a couple of government agencies and a couple of universities going, can we connect these servers together, or mainframes in that case, and communicate? And then from there, they went, great, we've got connectivity, but we've also created a vulnerability. And security's played this catch-up game. So bending the curve is really figuring out how we can get our security teams, operations, and models in pace with the threats we're facing now. Can we prevent the threats? Can we stop patient ones, those zero-day attacks? Can we reduce the toil, the cumbersome nature of sifting through security alerts, of securing and mitigating risk within our environments? And can we scale our talent? And now if you look at these three things and you think about the title of our slide and where we're starting, you can already see how this comes together. AI is not something that today is replacing my job, but AI is definitely something that can enhance my job. And if I can be a speedier SecOps analyst or a speedier cybersecurity professional, if I can have a less toilsome way to do my job, we're going to start hitting that curve better. So let's see how this moves forward.
So
Yes,
when was the dawn of information security, and were you there?
Let's see, the dawn of information security, I don't have a date I can pinpoint on it, but if it was post 96, I was working full-time in IT at the time.
Okay, so you were there then.
But my start was in I picked all the right technologies getting started. I was a certified Novell administrator and a Lotus Domino administrator.
See, I knew we had something in common.
Yeah, I picked the long race right there. But so as we look at that, I think James is going to elaborate a little bit on the history of this, but I've always found it interesting. Like, even if you look at the dawn of AI went into this hype bubble, and we all started talking about these LLMs and all these other things. And then after everyone got excited, you had some security professionals going, but wait, there's some security implications here. We're always following the trends. And so how do we fix that curve? Well, we need to make a shift. And the shift starts with moving from manual processes to manual assisted processes. And the manual assisted process is the key piece to feel safe, warm, and fuzzy with this, because we're not saying let's put the machines in charge and let them make all the decisions. We're saying let's use the machines to make the decision faster and with better outcomes than it was when the human makes it. And then we transition to the next stage, where as we build that trust, as we build the reliability in the systems, we move into a more semi-autonomous stage, where some things can be automated decisions, some things will still need human intervention. And then theoretically, where we're going to shift to over time is the ability to offload much more of this into autonomous systems. Where we sit right now at this point in time is really this shift from assisted to semi-autonomous. And this is going to be one of the largest gap closers in chasing that curve. So general purpose versus specialized LLMs is going to be an important concept here. Most of us as lay people or even tech people outside of the AI space are going to be familiar with general purpose LLMs. I can go to my choice of general purpose LLMs like Google's Gemini, and I can have it write me an essay in the format of Mark Twain. I can have it build me a business plan for hot dog popsicles. I can have it do just about any random thing that comes into my head. But it's not necessarily super awesome goody pants at any one of those things. That's where specialized LLMs come into play. And I think this is where it's going to get really interesting as you start thinking about how AI can enhance that security operational model. So let's take a look. When we look at that general model, they're not tuned for something like a security task, right? They're tuned on written language, on photos, they're tuned on video, they're tuned on gobs and gobs of internet data, mostly consuming the data that exists on the internet publicly to be able to build their knowledge base from which they create their outcomes. When we look at security, there's a couple of problems with that when you look at a generalized LLM. One, the breadth of everything they do creates a lot of computational waste if we're only going to use it for security. And computational waste equals heat, cooling, power, cost. The other side of that is that a lot of the security data it would need to be trained on is data nobody is making accessible. Why would you give away the keys to your security kingdom? Why would you provide an LLM the learning on every security incident you have? Now let's take it from a different angle. What if I'm enterprise customer with offices around the world and I'm a huge company and I build a specialized LLM for myself with all my own security data? That's great. It's a lot of data. It's security focused. I have access and authorization to give it to it, but I'm one company. That only shows me my myopic view of the world. What we really need is something more tuned to the broad security world and specialized to being able to address security problems. So if we look forward, what we really need is specialized security large language models and platforms that are designed to use them. A platform is going to use it based on your user inputs, prompts that you would be familiar with on a general model, very similar idea. But the learning model, the data, the process behind that LLM that's feeding you the answers is trained specifically on security data. Now, where this gets interesting is to make that specialized security LLM work effectively, you need what's scientifically known as a metric F-ton of security data. And to get a metric F-ton of security data, there's only a handful of organizations on earth that will actually have access to that level of data to properly train and feed a security LLM. So that's the crux of the difficulty to get to what you're seeing on this slide. A security LLM that can understand what you mean in the context of, is this file malicious? Which threat actor steal Gmail credentials? Or which threat is the most risk to me right now? So if we move forward, what we're looking at in these security-specific LLMs is the ability to have a model that's specifically trained on that metric F-ton of security data that is typically privately held and not accessible to all the LLMs out there, and giving it the ability to look in a fashion that protects the data you have against its learning model database so that it can start to answer security questions for you in real time that help reduce that toil and the cumbersome nature of SecOps. So think about it this way. Think about the idea of CVDs. CVDs are these known vulnerabilities. There are thousands of them out there. But out of the thousands that exist, there's a bunch of different categories of how much risk I might have to that. First, maybe it's a Linux vulnerability that CVD discusses. If I'm not using Linux servers, that's irrelevant to me. Maybe it's a specific CVD that's focused on the financial sector and I'm in oil and gas, so that's not relevant. How does my team decide what are the risks we have to focus on first today? They do it manually. How does a team today hunt a threat through a system and correlate all the contextual information of how that threat got into the system, how it's propagating, what it's doing, what it's touching, how it's using wall bins across your environment to execute its problematic commands? The answer is we do this very manually with our systems today. These are things that AI in its current state are very good at doing at much larger scale in a much faster fashion. So how can we do things like, does this file, blah, 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 cause any specific network behavior? This is where a special trained security LLM or a security specialized LLM comes into play. So
I do apologize that our fancy animated GIFs are not coming through, so it just looks like a blank screen. But it'd be a lot cooler if that actually worked. I don't know what I'm going to blame.
You feel free to blame me. It is my operation of the slides that's making these fail. It is because I'm not using a specific LLM that has been trained to help me use slides. The summarization here, what it really does is it's making sense of volumes of information. Now, the interesting thing here is the thing that the human brain is beautiful at is taking a bunch of abstract information and matching patterns at it. That's what the AI is doing for you. But what it's doing is doing that at much larger scale and much faster so that it can help feed you the exact information you need right now, prioritizing what you're doing and find correlations that you won't be able to find because you don't have an infinite amount of time to find it. And now think about how important time is when we're talking about cybersecurity and risk. Every second there's a potential vulnerability on my systems is a second where I could be losing money, losing data, losing risk, getting fined. The faster I can mitigate that risk with my response and my triage, the better off my security outcome will be. So if I can reduce that time by 1%, 10%, 100%, it doesn't matter how small the percentage is, it has a measurable effect on business impact. So as we look, the cool, or what would be great, is to be able to summarize all events involving users that opened an email from domain.com. I know that domain.com has an exploit. I know that it's active in my environment. Show me everyone that could potentially be affected. I can do this really fast with natural language search. That's pretty cool. I can look at how a specific threat like APT43 operates and get an idea of how it operates so that I can look at my environment and see if there are vulnerabilities for that or if it's operating in my environment. I can have AI very quickly summarize MITRE's framework and suggest which access token manipulation in their documentation might be something to look at. What gets cooler than this is when I can take those, which kind of get me up in the morning type cool, and get into the super cool stuff. When we get into the cooler stuff, now we can look at what actually happened. This specific file with this specific hash was detected at this point by this, with this. If you look at this little screenshot blurb and you just spend 30 seconds after this video and hit pause, the detailed amount of contextualized information that is correlated across multiple systems to be able to bring me up a 30-second summary that gets my digging for the problem started faster is amazing. It's a mind-blowing capability when we start to look at the idea of understanding our vulnerabilities, measuring risk, and hunting our threats. So when we look at threat hunting specifically, AI-assisted threat hunting's got its cool and its cooler. On the cool side, we get the stuff that is better than what we're doing today. We get hunt for a list of IOCs on my network. Go show me if these things exist. We get the ability to ask an easy, simple human question. What common ways attackers compromise cloud service accounts? Or why is this target IP associated with this particular file? But what gets cooler for that is the ability to natural language go hunt for bad rabbit on my network. Have I been impacted by APT44? Now, what I want you thinking about when you're thinking about this is not just, I have this rocket science whiz kid whose propeller spins 10,000 miles a minute, and he can do all this already. You do. He's great. Keep him. Give him a raise. But you need 10 more of him. Do you have the budget? Does your HR know who they are? Are they already in the interview process? Or do you have some tier 1 people that are awesome with a lot of potential ahead of them? This takes that potential and accelerates their speed to be the rock star. This allows your tier 1 to operate alongside your tier 2 and tier 3. This allows you to grow and train your team while actively eliminating threats in your environment more quickly. So if we look forward, we've got concepts, right? We've got things that go on. We've got WannaCry, the ransomware attack there, we know. We've got Google's generalized LLM, Gemini 1.5. So how do these things come together in a SecOps world? We know this is malicious. We're able to look at the model. We get the ability to understand exactly what's happening. We get the ability to summarize it quickly. We get the ability to use natural language. Now, here's an example I love. I have spent a limited amount of time in various SIM and SOAR products designed to help me understand and threat hunt threats within my environment. And what I've found in the majority of tools is that if I am an amazing query writer, I can find any information I want as long as I can articulate the appropriate query and I have 65 minutes to go get a few cups of coffee while it runs. What I'm able to do with basic natural language utilizing a specialized LLM is light years beyond what I can do with queries. Not only does it enable me to get to the results instantaneously, much faster, but it also allows me to learn the complex syntax as I'm doing it. So I don't have to start with a manual and crank error codes into syntax all day long until I get it right. I can start with a natural language query, learn the language behind it, refine my prompts as I'm growing as an analyst. So moving forward, that's why I feel there's a lot of power in how we're incorporating specialized LLMs into the SecOps practices that we already have to be able to catch up with that curve, reduce that toilsome work that happens in the SecOps world, and drive better security outcomes across our enterprise organizations. And hopefully I didn't butcher that too much.
Oh, Joe. It was so great until slide 12, and then it just sort of went a little bit off the rails. But your recovery was pretty good there at the end.
I saw slide 12 and I'm like, yeah, I don't got it.
Yeah, I knew that WannaCry slide was going to throw you a little bit for a loop, but I was digging it all the way up through. Except you used one of my favorite technical terms, which I think is SAGP, super awesome goody pants.
Super awesome goody pants. That's like the creme de la creme.
Do you try to insert that term in every time you do one of these? I mean, Sabrina, have you heard this before?
I have not. There was a couple new ones today. I specifically want to know how much a hot dog popsicle costs because that came up. Didn't expect that. There was another one. Oh, the metric F ton. That came up a few times. Bonus points because that came up a few times. But yeah, the goody pants. That was a new one too.
Right, exactly. And how do you measure an actual metric F ton? Like, Joe, do you have like some sort of a truck stop style scale or something like that? Maybe you've got one in your backyard. We can go.
I live right next to the port of entry. I just load up the truck, drive down there. They weigh me in and out.
Well, check it out. They give you a discount. You bring them so many metric F tons of stuff to measure, right? You got a punch card is the way it works.
Get my 5th metric F ton free.
Exactly. That's good.
Awesome. Yeah. Well, James, are you ready to enlighten our audience with what you actually came to talk about?
Yeah, I guess so. I got to tell you, is the abbreviation for this thing TDK? Is that what we call it?
Yeah, TDK.
I'm super old, but this is what I thought of is one of these things, right? Like this is a TDK to me.
Yeah, so that is a TDK. This is
that's how you got me. I'm like, oh, maybe they're going to play something on audio cassette, and I love audio cassettes, and I'm in, right? So
just for you, we will release this on magnetic tape.
That's good.
Great. We're happy to. Yeah.
Awesome. All right. So I'm James Brodsky. This is a shortened version of a deck. My colleagues have recently been delivering this in public. So the Mandiant MWise conference in Denver 2 weeks ago, we had a version of this. We also did a version of this at Mind the Sec in Brazil. High-level introduction to how we at Google are thinking about and implementing in our products the use of generative AI. It's about, we're about 18 to 24 months after the world changed with the general release of ChatGPT. This deck is designed to be as product agnostic as possible. Therefore, I thought it was a good choice for this particular outing. But you'll see that this particular version is Google branded. So let's get on with it. All right. So the future is now. That is a bold and markety statement, and it's in a very large font. So what does it mean? Doesn't mean I can tell you who's going to win the World Series. Doesn't mean I can tell you who's going to win the presidential election, although I wish I could. No. What it does mean is a lot of the potentially overhyped and overpromised statements surrounding the use of generative AI technologies to help our blue teams defend their organizations is starting to actually come to fruition. So today there are some real and some tangible benefits that Google's customers and customers of certainly competing security operations platforms that are doing some of these similar things are realizing from the embedding of the generative AI technology into products. Hopefully over the next set of a few slides, you'll understand what some of those benefits are. So there are these decade-old challenges when it comes to cybersecurity. These are some of the problems that we're aiming to solve with generative AI. These aren't new issues. We need to identify the adversaries that are targeting us, both from a proactive manner, from a reactive manner. What are the threats that are in the landscape that are that are out there? How are they targeting us? What resources are out there in the environment that are affected by these threats? How can we secure ourselves better against these threats? Then we have to make the burden or the toil that is facing our cybersecurity teams easier. How can they do their jobs more quickly, more accurately as possible? How can they get more consistent in their approach to how they're solving incidents? That's also very, very critical. Then, of course, there is this persistent skill shortage. We've been hearing for years and years and years. This is across all aspects of cyber. How can teams get the most out of their tools so we can indeed do more with the meager amount of headcount that we actually have? Because these headcounts certainly don't grow on trees. When was the last time you heard a SOC engineer or analyst say that they didn't have enough to do? I personally believe that generative AI isn't going to replace your SOC engineers, right? It's not going to allow you to hire a bunch of bank tellers, for example, and turn them into SOC analysts overnight. But it sure can help up-level a junior SOC analyst and make them a senior SOC analyst much more quickly. So really, we're kind of on a multi-year journey when it comes to Google. So if you're a SOC and you're not leveraging any AI, we call that a manual SOC. Well, of course, there might be some pre-built automation and some logic. All of that these days is usually hard-coded, right? Deterministic rules, lots of different kinds of deterministic reasoning. Humans are still providing a lot of the mental energy. They research threats, they write detections or alerts, they write incident reports, maybe they create or they tweak, the older rules that they have, and then they keep following that cycle around and around. And the problem is that this doesn't really scale very well. And with the growth of cloud, more endpoints that are out there, mobile, digital transformation, this doesn't really work very well long term. We can't afford to have that much people power in our SOCs. So the next phase is assisted. So now we're like September 2024, we're starting to see this. Organizations are at different levels of maturity to be sure with this, but the use of AI has really started. And in most cases, this is a dynamic where AI is assisting the humans. It's making them faster, but the humans are still doing most of the decision making and they're doing most of the critical thinking. But AI is reducing those rote tasks, the manual burdens, the need for a human to be involved, the need for a human to be consistent most of the time or each time. And the LLMs are incredibly valuable in the research phase. Go and tell me about this particular latest ransomware strain that I think I need to worry about. Summarize what you found, synthesize me some content for it. Or maybe I tell the LLM about a threat actor group, and maybe I've got 100 or 1,000 threat intelligence reports that are out there that I would have to analyze manually, but I can only deep dive on the most important parts. So the LLM can tell me what the most important parts are. Or maybe I'm writing detections, for an emerging threat, but I recently moved maybe to Google SecOps from another platform like Splunk, and I have no idea how to do that. So I do know, though, the AI can help me get started, or maybe even create a working detection completely by itself. So that's where we really see ourselves now. But what about the future? Now, this is where AI starts to become more ingrained in the workflow instead of just doing the research and the summarization. So action starts to get taken, decisions start to get made. Everybody sort of gets a little bit nervous when we talk about this, but when we say, hey, AI is going to start to do these types of things, but let's be clear, we really are starting with low-risk things, high-confidence situations like, hey, the last 100 times this happened, this is what we did, so we're going to do this again, but we're going to do it as an automated step. But still, like in terms of the researching and the acting against and the closing, we want humans to take those final steps. So maybe the AI research, goes out and researches a threat itself. It suggests remediation steps, but the human approves those steps. Huge time saver, right? But the responsibility is still lying within the realm of the humans. And then finally, all the way to the right, autonomous. Now, the AI is more of a partner. It's driving more of the decisions itself. It's autonomously triaging and responding to alerts, and it's telling users what it did when it's done with that. This only works if the AI has full context of the user environment that we're trying to protect. It's fully trained. Users have full control over it and can do overrides where necessary. We are honestly to be pretty much years from this technically, but that's what we're striving for. So general purpose versus specialized. Not all LLMs that are out there are created equal. In order to do anything like what we just described in the previous slides, we have to have specialized LLMs to help us out. So LLMs are fantastic, but in general, they are generic models. They are trained once on a large corpus of data, and then a version is released. And this means that typically they're trained on static data, and this leads to two problems. And one is that the LLM doesn't necessarily have the latest up-to-date information, unless it's going to use RAG or something like that to augment. For example, if the LLM was trained on a set of data that doesn't have an emerging threat that was released just yesterday, it might miss something. Or if the LLM is trained to service a financial institution, but you're a hotel chain, it might not be making the best suggestions for you and your environment. The fact that LLMs work on probability might be accurate enough for some security use cases, and it might not. And just like humans, these LLMs typically produce the best answers and assistance when they have the most context. So to reap the benefits of security AI use cases, you have to use a specialized security model and platform. So as you might imagine, we at Google have one. We call it SecLM. What are the different things that go into it? So first off, data. In our case, we're feeding SecLM with our own proprietary threat intel. Mandiant, VirusTotal, Google, as well as publicly available information from CVEs, MITRE ATT&CK framework, etc. This helps reduce and almost eliminate hallucination. And the reason why is the model is not trained on all the public data that's out there, including data that might be inaccurate. We're being very specific in the way we train this. Then models. So on top of the generic Gemini 1.5 model, which now supports 2 million nodes, we have security-specific models. With agents, we have a security-specialized chatbot that can apply the model to the data, give the correct responses, provide next steps recommendations, and so on. And then finally, data sources. This is where we layer on your telemetry, such as your SIM logs. So when a user enters a prompt on the left-hand side, they use natural language. The SecLM models have access to all of this stuff in the middle, and they can leverage any and all of the information. This means that the response won't be generic, but instead it is grounded in security-specific information. So as you can see here in this response, we're taking the cryptographic hash, we're passing it through the SecLM model, looking for behavioral attributes, then scoping these behaviors to what the malware associated with this particular hash that's here does on our network. And then we're summarizing that, summarizing the behavior back to the user. So 3 examples that I'll go through really quickly. There are many more that we're starting to apply, but limited time. So here, we see a user taking an existing detection rule from our SecOps platform and asking for a description of this particular rule in natural language. So if you're unfamiliar with the YARA-L language that the SecOps platform uses in the Google side, it could be hard to read it and understand exactly what it is that it's doing. But after we feed it through SecLM, we get a much nicer to read example. We've seen some of our partners, as a matter of fact, use this technique to convert detection rules from other SIM platforms to ours, using that natural language as a sort of a Rosetta Stone between the two. So what they'll do is they'll have SecLM first take a rule like this, understand the detection, convert it to natural language. They'll take that same natural language, feed it into the platform again, and do the cycle again and say, okay, now convert this into my target language of SecOps, and then it can produce a YARA-L rule. And believe it or not, it's been very, very successful at doing that with that type of approach.
So you're basically using SecLM to take an existing rule from another platform, turn it into pseudocode, then using the pseudocode to build Google's code.
And it's astonishingly accurate in terms of actually using that pseudocode step in the middle. Wouldn't have believed it if I didn't see it, but in fact, we've seen it work pretty well.
It makes sense because you're breaking it down to its most basic process so that it can be rebuilt from the ground up to do that in the right platform.
That is correct. Not perfect, right? But it's getting there. So then, summarization extends a little further, right? So we can have our SecOps products summarize a lot of event output from a search, or automatically research an APT group, not only tell you about how it operates, but extending past the summarization to investigation. So if I'm going to ask my SIM platform, how does APT43 operate? That's fine, it might tell me. But wouldn't it be better if from that point forward it says, well, let me go and see if APT43 actually exists in your environment and start doing that search automatically, right? So then on the right, you can see how we've summarized a security incident very quickly by asking AI to summarize everything that happened in an incident or in a case put that right front and center for the analyst, including making a hash that we already automatically correlated against threat intelligence, and we knew it was malicious. We'll turn that red, and then you can click on that and drill further. Getting that information right in front of the analyst so they know what to do immediately upon entering the case. For threat hunting, right? Let's say you've done your research. You either done it manually or you've done it through some sort of AI assistance. You know the adversaries that are targeting you. You can then easily ask in natural language for the platform to go and search for lists of indicators or types of techniques for you. But what about something more advanced, like you see here on the right? How about just providing the adversary name like Bad Rabbit or APT44? Now the APT has to do an awful lot of work, right? Or sorry, the AI has to go do an awful lot of work. It's got to go figure out what APT44 is. It's got to understand some of the recent indicators the APT44 might be using, understand the data sources that you have in your environment, understand the techniques that are used, and then start to search through your data and return results. And that type of activity, that thing that I just rolled off in the past, might take months or even days for an analyst to get started with. Here we can actually get started with a targeted hunt with just a simple prompt like you see. So here's something we did just recently. We added LLM-based analysis to our code insight capabilities in Google Threat Intelligence. So you might remember the WannaCry ransomware attack back from 2017. At the time, it was one of the biggest and most detrimental ransomware events to date. But you might have remembered early in the attack, like the first couple days of the attack, there was a malware researcher that went through and found an interesting domain in the code and just sort of registered it on a whim. He just said, no, maybe there's something that's reporting in here. Maybe I'll use this as a honeypot. Maybe I'll collect some statistics about where this malware is executing around the world, but I'm just going to go and register this domain out there. When he did that, essentially this ransomware stopped in its tracks, right? Just sort of inadvertently. And historically, you might need somebody like that, like a malware researcher, to go through and do that kind of work. Well, in this case, we took the ransomware binaries, the actual WannaCry binaries from back then, fed them into our Code Insight platform, and since Gemini 1.5 has an extremely large context window, it could analyze that sample in a single pass after it did the decompilation and disassembly. It basically resulted in like a 1.5 megabyte assembly file. It identified the kill switch domain in about 46 seconds. And it identified that that domain is one of the ones that's contacted. And if it was contacted, the code would stop. So obviously to do something here, back then you would still have to register the domain, right? But still that ability to go and analyze a piece of code after decompiling it, after disassembling it, is really impressive to do in that limited amount of time.
Now, James, just for our audience here, because we have a large mix. When we talk about context window within the idea of AI, we're conceptually talking about the amount of contextual information the AI can use for its current processing.
Correct, and how much information it can process without having to break things into chunks. That's right. Okay. Yeah. That's right. And here on the next one, you can see, the output from the WannaCry analysis. And that sums things up, everybody. So hopefully you now know a little bit more about how Google's customers and security operations analysts around the world are starting to benefit from real-world, practicable, shipping, included features of generative AI in our products, and obviously as well in those of our competitors too. So if you'd like to learn more, see some live demos, etc., contact me for a follow-up. And that's it.
Well, I got to say that those last two slides, James, they made a lot more sense when you said it.
I figured.
You tried. I mean, insert clapping here, James. That was great. That was great.
There's so many interesting things you hit on, and one of them is the idea of training a specialized security LLM. Because I know when you and I first met, and I was starting to wrap my head around some of this stuff and the rest. The biggest problem I saw in that is who has the data required to train that LLM. Right, because you're not talking about a lot of names, right? You're not like, maybe the FANGs, maybe, right? So now you're down to that few. But when you look at why Google can execute on this and why they're uniquely differentiated behind a pretty solid moat, it's not just the scale of Google as a company. It's look at what Google touches. 6 billion browser installs for Chrome. And then the next 3 most popular browsers are built on Chromium from Google in the first place, right? So like the data they touch at endpoints, the Gmail users, the acquisition of VirusTotal, Mandiant, the amount of data, security-related specific data brought in is interesting. Right. And then the part that makes that so attractive to me is Google did something nobody does anymore many years ago, and I wish more people did it. When Google got breached, your CEO said never again. And not just some like Wall Street, get my stock up. It was like, here's some money, find the people, make it go away.
That's right.
And you reinvented security from the ground up. It wasn't, how do we tack on the next thing like Frankenstein? It was, if we rebuilt for security from scratch, what would it look like? And it started from there. And so when you bring these things together into that platform and you start to apply that SecLM, the results are amazing. My first time sitting in Google's SimSOAR platform, right? So their security platform and security orchestration automation response platform. There's a thing in the platform for automated response called a playbook. That playbook gets triggered based on an event, and then it executes a series of commands to automate a security response. It's not rocket science to create a playbook, but it's also not simple. If you're new to the platform, you're going to start with a lot of documentation, and about half-day through the documentation, you'll start fumbling around trying to build a playbook and testing it.
Yep.
With SecLM, I go in and say, build me a playbook to do this. And it gets it about 75% right. And I'm looking at a playbook that I can now tweak to perfection in minutes versus documentation research.
Massive amount of time savings, and that's exactly what folks are seeing. And in fact, what's really nice is that the incident that you talked about that happened back in 2009, the technology that was developed internal to Google to help us recover from that particular incident is, in fact, the same technology that now exists in the SecOps platform, and we're making available to anybody, regardless of whether or not you're a Google Cloud customer or not, making that available for anybody to be able to license and use.
Yeah, I think it's brilliant, and I think it all comes together. And it's funny because I sit in the industry and watch, like, I'm sure you're familiar, but there's a lot of security vendors out there now talking about platformizing their security products. And so they have all of these interesting independent little security components that they've bought, borrowed, or stolen to create their portfolio. And now they're trying to kind of like hash them together. Whereas you all started from the platform approach and added.
Yep, absolutely. A little backwards, but we're getting there. It's still early days, right? We've been at this a little while, but I'm amazed every day. There's something new to dig my claws into and to understand a little further. So, yeah. So
Sabrina, other than the fact that James is more articulate, better looking, and knows the space better than I do, what takeaways did you have?
Other than that, I will say this is so mark your calendars right now. This will be the first and last time I compliment Joe. The fact that you brought up metric F ton, although I am slightly disappointed we didn't get to use the beeper, There's
a beeper? You didn't tell me.
There is, yeah. So next time, we highly encourage swearing here because it just lets us use the buzzer, Yeah. So next time. Look, there's still time. If you want to just go on a giant, rampage.
We forgot a chance to bleep.
Son of a bitch. Here we go, you guys. But I mean, Joe, that with the hot dog, popsicles, and the goody pants, there were 3 goodies in there. I wanted to make sure we tracked all of those. It is by far, I mean, James, it's hands down, you won. It's a Brodsky for the win, But like I said, I will give Joe that one-time compliment in what? We've been running for 2 years, Joe. How long has the show been going? So there you go.
Yeah, quite a while. I should probably get used to the losing. One of the first things I remember my mom telling me, Joe, if you were born a loser, just accept it. It'll be okay.
But isn't it more fun to have hope?
Fun's the word I'm looking at.
And it's super fun to actually get paid for this too. I mean,
that is cool. Right. That turned out good for all of us.
And I really love where this stuff is coming together and going. And I think you hit it in your deck really early on, but the idea of toilsome tools, right? And look, I have a background in data center and in networking before I got into security, but in all of these domains, we have toilsome tools. We have multiple dashboards. We have all these different things that some human is sitting there correlating back and forth. as we're able to use these modern technologies like LLMs to do that correlation, we can alleviate that. It's no more about staff replacement. It was. Automation was about staff replacement for many years. Now it's about how do I keep up? It's how do I keep up without tripling my staff every year?
Yep. Okay, well, I'm expecting you to send me the cassette of this reporting as soon as you're done. So please get it in the mail.
Excellent. I'm pretty sure out here in Podunk there's a FedEx I can find somewhere.
I think if you know what a cassette tape is, you get some kind of a special continuum prize. Maybe that jacket. See, I needed another swear in there. That little jacket sticker of, I beat, and then it's like, Joe, you on a donkey, your face on a donkey. Maybe you get like a sticker. So comments, if you know what that, hold it up again, Brodsky. If you know what that is, I'll hold it that way. If you know what that is, let us know. We'll send you a big prize.
I'll go one further. Like if somebody actually knows what this is, I will dub the audio of this entire thing to one of these and send it to that person. I'll even send it internationally.
There you go. I can't do better than that. He'll sign it. Will you sign it?
I'll sign it too.
I'm disappointed you didn't bring in something more obscure like an iOmega zip drive.
It's still time.
There's always next time, Joe.
That's right. That's right.
Well, James, I absolutely appreciate it. I think this is fantastic. I hope our audience got a little bit out of this. For one, I think you should talk to James and his team, especially if you're looking at your architecture. They have some interesting stuff, and I think they have some very innovative and differentiated stuff. But beyond that, start thinking about real-world, tangible use cases for AI that aren't these pie-in-the-sky futuristic things. Right. Look at how you can apply it to the problems you have today that are taking up your organization's time.
Great.
And on that note, I'm good.
On that note. All right. Until next time. See you soon.
All right. Thank you, Joe. Thank you, Sabrina.
Bye.